Assembly language programming is different from higher level language programming in one very important way. All modern higher level languages are block structured. That is, they hide branches inside do's, whiles, and ifs, but in assembly language you have to specifically include those branches in your code. Every decision made by your code is a two-way decision. The code either branches to another location or it falls through to the code directly below. But that's fine, because that's all any language can do. Higher level languages just hide this fact. This is a program that determines which numbers within a specified range are prime numbers. Now, this is not the fastest way to do this, nor will this program work for a very large number, but it does show you what I mean about decision making and branching. The first thing this program does is prompt for a lower bound and an upper bound. All primes between these two numbers will be found. It does so by guessing at the possible factors of the number. If it can't find one, the number is prime. To start out, the value of the factor is set at its lowest, which is 2. The loop starts out at its very top by testing for the size of the factor. If the factor squared is larger than the number being tested, that means that no factors of the number have been found, so we have found a prime number. On the other hand, if it's not too large, we drop through to the code below. This time the number is divided by the factor to see if there is a remainder. If there is no remainder, that means the factor divides evenly into the number, and this number is not prime, so a jump is made out of the loop to find the next number. Otherwise, we are still looking. 1 is added to the factor, and the program loops to test the new value. Every time a prime is found, that number is displayed. The out integer function is called to send it to standard out, and the out string function is called to output a new line character following the number. Notice that there is no branch at the bottom of this code. That's because at the bottom of this code, the time has come to go to the next number as being one of the primes, and the code that does that is right here below it. The previously tested value is stored into walk, and it's time to move to the next number to be tested. That's done by adding 2 to it. At the start, the value was set to an odd number, and all primes are odd, so 2 is added to get us to the next odd number. The new number is tested for size to make sure it has not gone beyond the upper limit. If it has gone beyond it, we're done. If not, the factor to be tested is reset to 2, and a jump is made to the top of the test loop. The action taken for done is nothing you haven't seen before. The registers are restored, a 0 return is put into EAX, and return is made to the caller. If you examine this code and the code of the previous examples closely, you will notice that certain patterns repeat themselves. This repetition goes on. The more assembly language programming you do, the more repetition you will find, the more of these patterns you will come across. This is what led to macros, which are coming up soon, and you'll see how all of that led to the idea for higher level languages. Different higher level languages automate different things, but I'm getting off the subject. The main line for this program is very simple. All it does is call the assembly language function. Here's how it runs. First, it prompts for the lower bound of the range of numbers. Then it asks for an upper bound. Once you enter the numbers, all the primes between the two numbers are displayed. This program could have been made more robust in a number of ways. The upper and lower bounds could have been compared to make certain the lower bound is smaller than the upper. Also, extended math could have been used. The upper range of this program is limited to the value you can store in a 32-bit integer. But you should understand everything in this example. There is nothing here that hasn't been covered in detail at some point in this course. You should examine this source code and make certain you understand how it works, every detail of how it works.